What is diffraction of light? Diffraction is the ability of light waves to bend around obstacles. That is, if you put a torch, the light will be straight. But if there is any obstacle, there is anything which is in their path, now this light rays or the waves, they will bend. They will tend to change their path. So this is an experiment you see. Now here a person is giving some energy or putting something in the water. The water is still, but whenever he is hitting with some object or some ball, there are waves. The water was static. Now these waves, the pattern they are going, the pattern they are moving. This is the pattern. So water is actually the energy being transferred by the hitting object. So there is a crest is the above part, and trough, which is the lower part. And you see it is periodic. That is, if you put any obstacle, you will see this phenomena in beach also, in water, because the water is moving. And if here you see the light rays, if there is an object, you will suppose that, okay, the image should be very clean like the object, but the light rays are bending. So you will not see a clear image. You will see a fuzzy shadow because of the bending. So water waves, they easily bend around obstacles. Also the light waves, they also bend. So what do you see with this fuzzy shadow or this experiment which I just indicated, or anything which is put in the ocean? You will see that light and wave, they bend. So light, because most of the scientists, they talked about wave nature, some talked about particle nature. So light behave both as a wave as well as the particle simultaneously. Coming back to the water waves. Now if you put something in a still water, why these waves are in wavy in nature, periodic in nature, up and down in nature. So you see here an example. There is energy. This wave is nothing but the transfer of energy through water. So now what will happen here if you just put a small gap? When you put a small gap, the water, because the gap is small, if the gap is small, water, if the gap is not small, the diffraction, or you can say the bending will be less. But if the slit or the gap is small, then you see Huygens principle comes into action. Huygens or Huygens principle. So Huygens principle or Huygens principle. Here you see a new set of waves is observed emerging from the gap to the wall. Because now in this gap, every point acts as a new source. Why it is round? That comes from the Huygens principle. I'll just talk about that. So either in water waves, or I'm talking about water waves because it is very common. You see it. What about light? We will try to make an analogy. Now here you see there are two gaps. So water moves like this when it passes through a gap. It is coming in a straight wave, but because of this small gap, it will bend. So Huygens principle, what it says, when we'll go to the light version, Huygens principle says, or Huygens principle says, that any wave, or you can say a light, every point act as a source for the next iteration, for the next energy to be transferred. So the point source transfers the energy in all the direction, that is omnidirection. So every source, say for example the waves, every source is also transferring the energy to all the omnidirection. But because the energy is coming from one side, that is why it is only, you see, forward curve, and this curve is nothing that has come from the Huygens principle. This round shape is actually a sphere, omni, and this is Huygens principle, that every point acts as a source for the next iteration, next step. So now if you see, there are two slits, two gaps. So now these waves or the light, they are interfering, they are cross-acting, they have some kind of combination, and this kind of combination can be of a phenomenon.